Hello, hello. Yes, everybody can hear me fine, I think. It's 2:02. I suggest that we start this session, so the first session of the afternoon. Welcome, everybody. Welcome back. Yes, this session is on driver behavior and acceptance of cooperative, connected, and automated mobility. So I'm very happy to be here and to introduce to you 4 projects that have replied to our H2020 call on this very important and timely topic. So my name is Susanna Kraak. I am a policy officer working at DG Research and Innovation and working on all matters CCAM. And indeed, driver behavior and acceptance is a very key topic when it comes to deploying CCAM systems and services. There are many public concerns that have arisen recently with increased automation, with increased connectivity, not just in terms of how to handle that as either a driver or a driver in the loop or no driver, but also in terms of the wider effects that CCAM can have on data privacy, on ethics, on safety perception, and so on. And so we all know that the deployment of CCAM will affect different groups in different ways, users, non-users, other road users. We have to anticipate basically as best as we can these interactions and also these effects. This depends, of course, also on the different use cases that we're looking at and also on the different modes of transport that we're looking at. And I think that the Drive to the Future project looked a little bit across modes, so it will be interesting to hear about that. But ultimately, research under this topic really aims to make these interactions between vehicle, between driver and direct environment trustworthy. Trustworthy in preparing for a safe and inclusive transition to CCAM. So I think today, from human-machine interaction, but also from acceptance of these CCAM systems and services, these projects have many things now to share and insights to show to everybody. So without further ado, I would like to call to the stage José Solas, who is the head of innovation at the Biomechanical Institute of Valencia, to present the SUAVE project, which uses human-driven design to ensure public acceptance of connected and automated vehicles, exploring public's perceptions, emotions, and also attitudes. So the floor is yours.
Hello, good afternoon. Thank you for inviting me today. And thank you for being here after lunch. I hope not to be very boring. So I'd like to thank also to my colleagues from the other sibling projects. So it's been a great pleasure to work with you, with Lila, with Alessandro, with Frederica during those years. So it's been great to share the project with all of you. So today I'm going to give some words about the SUAVE project, coloring automated driving with human emotions. SUAVE belongs to the H2020 MG 2018 in 2 stages. It's a research and innovation action of 42 months of duration. The project finished last year, and it was about like 4 million euros. The project has been composed by a set of partners from different specialties. The main idea of SUAVE project was, as was mentioned before by Susanna, to try to understand which are the key factors of acceptance of autonomous vehicles level 4, level 5. I like to think in this project like a sort of forecast of the future about how the new vehicles should be designed, how the new vehicle should be conceived in order to guarantee that from scratch they're going to be accepted. We have to think that level 4, level 5 is something that is familiar for most of us, but for the general public it is not. So when we talk with people about what's a level 4 level 5 autonomous vehicle, they don't understand what we're talking about. And mostly when we talk about level 4, people tend to conceive autonomous vehicle like a complete level 5 vehicle, like a door-to-door system, instead of something that can evolve. That's something, I wouldn't say dangerous, but something that should be taken into account when we are thinking of conceiving these kind of vehicles. The consortium necessarily need to tackle different perspectives. So we have partners from RUG and Verecom, specialists in social science, who tackle all the part related with interviews with users from the early stages of the project. They also made Wizard of Oz technique level 5 testing, introducing people in a car that was driven by a real driver, but the people in charge thought that the vehicle was driven by himself, so we could measure and observe the reactions of people when they thought they were in a real level 5 vehicle. Also from Human Factors Engineering, also from IBB and our colleagues from IDIADA, who tackle all the solutions related with how the vehicle should modify its behavior in order to enhance the acceptance. The colleagues of TUM, who were specialists in the vehicle dynamics, and Bordeaux and CRF, who work especially in two systems. CRF integrating the solutions, and the people from Bordeaux in the integration in a driving simulator that also include all the parameters, all the new functions of level 4, level 5. And finally, from technical engineering, University Gustave Eiffel, ESI Group, and Nextium, which propose different approaches. Nextium proposing solutions inside the car for measuring the reactions of the driver and passengers, and ESI developing software able to evaluate level 4, level 5 solutions in the earliest stages of development. The main objectives of the project, as I mentioned before, were to investigate which are the factors behind the public acceptance of an autonomous vehicle. Something that we discovered during the project is that the anthropomorphization, that means that the vehicle behaves like a people, like somebody, is key in order to enhance this acceptance. The feeling of that vehicle understand your reactions and your emotions is critical. And not conceiving the vehicle like something that brings you from A to B without any conscious about who you are or what you need, but to really understand that you are someone or you're a group of people with different feelings and emotions. The second is to generate a cross-cultural framework for ethical and legal issues for the development of the autonomous vehicle. This part was developed by VEDECOM, and something that is critical also is to understand which are the ethical aspects behind the autonomous vehicle. How do we understand that we are interacting with this kind of vehicle? And also to tackle all the legal issues, not from a purely legal aspect, but how they are understood by the occupants of the vehicle. Finally, to investigate and develop a model to monitor and interpret the passenger state. This is one of the keys of the project, and that lead to a concept called Alfred that we will deep into later. In order to guarantee that the user is going to accept the autonomous vehicle, we discovered during the project on the earliest stages of research that the vehicle was not accepted because there was not a feeling of safety or a trust in the vehicle. They understand it like a machine that was not sensitive at all of who they are or what they need. So from the earliest stages, we discovered that we had to go further, and we needed to develop something that was able to understand and interpret the emotions of the passengers. Not only the state of health, not only the stress, not only the drowsiness, but the emotional state. Once we understand the emotional state, it's a very valuable information, but we have to do something with it. Otherwise, it will be useless. So the next objective number 4, is to define the onboard services to influence on passengers' state and to improve their experience. So once we know how you feel, then and I have to change the vehicle behavior, I have to change the vehicle parameters in order to enhance your acceptance, in order that you really feel that your needs are covered. To do that, obviously, we don't have a level 5 vehicle, otherwise I wouldn't be here, I would be rich. So we use different kind of driving simulators, one in IDIADA, another one in IBB, another one in VEDECOM. Everyone has different driving simulators. And also, as I said before, a Wizard of Oz. That means a vehicle that's driven by a real people, a real person, that's behind the wheel. And finally, to generate and validate the developments and testing with participants. I must say that COVID made things somehow difficult. Probably most of you that are in the European projects know that made things difficult. So we just try to make experimentation with people or passengers that makes things even harder. So which were the results of SUAVE project? As I said before, we developed in the project something called Alfred. If you are as geeks as we are, Alfred is the chauffeur of Batman, so that's the name of Alfred, because Alfred understands what you are feeling, and then it changes the way of behavior. Basically, what we did is to develop a model, an emotional model that explained the 84% of variance in acceptability, and we introduced it in a prototype. What makes Alfred is to gather the information from heart rate variability and the information from the electrodermal activity using a Wristband in that case. And with this information, we are able to obtain two parameters that are valence and arousal. That means if the emotion is positive or negative, and whether this emotion is intense or is not intense. That creates a two-dimensional frame in which we can locate a point that represents the emotion, and this emotion can be somehow interpreted in words like amazed, happy, unhappy, etc. There are several studies behind that, and several models behind that. Once we developed that model, we validated using different driving simulators, so we are able to obtain which is the emotion elicited by different scenarios. For example, driving in a storm or in a rush. So then we obtain this level of arousal. What we do then is to apply different strategies to change the emotional response. For example, the vehicle change the lighting, change the simulated speed, give messages to the passenger to make them understand that something is happening, and then he has to feel quieter. So then we detect that we are able to change the emotional state of the passenger or the driver with certain messages or with certain ways of changing the behavior of the vehicle. That means that this way of communicating between the passenger and the car works properly, and finally we obtain that increased acceptability of the autonomous vehicle. Regarding the ethics, the architecture of the Alfred autonomous vehicle can change the way the car behaves, taking into account also the rest of the users of the road. This introduces a concept in the project as the empathic vehicle. In some manner, the vehicle is empathic because it understands the feelings of the passengers, and at the same time, it reacts considering the rest of the actors of the via. So it takes care of you, but also doesn't have any unethic behavior regarding the rest of the components. So finally, you can find in the project still in the website that's still available, deliverable 1.5 and 1.6 that covers the policy recommendations about ethics based on the ethical dimensions for policymakers and industry. Basically, that's Alfred, you can see here in the figure. So what Alfred makes is to understand the emotion with this monitoring the emotion and the cognitive perception state with this system. During the project, we did it using a Wristband. It's invasive, you can think, but the further steps that one of the partners in the project that Nextium started to do during the project is to transform this information that came directly from contact with the human body with something based in a non-invasive technology, in this case of Nextium with cameras. Indeed, we are in IBB, we are also developing this Alfred model to obtain information only from non-invasive sensors. So Abe give us the base and the knowledge to know that this is possible. Second, to understand and adapt the response of the vehicle, taking into account ethical rules. So the ethical principles of the vehicle respect the rest of the agents of the road. To adapt the response of the vehicle, we create a system called EMI that improves the interaction with other road agents. That means it's a module that changes the way of driving of the autonomous vehicle. It changed from, for example, a very aggressive manner to a more comfortable manner for you and for the rest. And on the other hand, we have everything that Alfred makes for the interior, for the passengers. It adapts the ambient. With our colleagues from IDIADA, we are able to change the setting of the interior. We adapt with a cognitive smart assistant. That's an HMI that gives you different kind of information depending on your emotional state and also depending on where you are in the road. And finally, it adapts the ride comfort with the colleagues of TUM. So finally, what we have here is a vehicle that doesn't behave anymore like a robot going from A to B, that understands you and in some manner sensitive to who you are or what you need. This is the emotional model that I was mentioning before, and this is the sort of representation of the emotion. So we are able to estimate the values of the balance, that's the pleasantness, and the arousal, disactivation, from the analysis of the physiological signals, as I mentioned before, the GSR, that the activation of the electrodermal activity, the sweating rate, and also the heart rate variability. If you remember these machines that detect you saying the truth or not, it's quite similar, because when you change an emotion, those two parameters change accordingly. Something that was, from a scientific point of view, that I must say that's surprising, but it works very well, is the accuracy of the system with an 89.4% of identification of the 5 emotions declared. Something that's also interesting is that originally the system worked offline, but during the project the system worked online. That means that we are able to detect in quasi-real time the emotional level. Regarding the adaptation, the system provides effective communication of information to the passenger, and there's a high level of commitment and situational awareness. And also, during the project, we developed also some systems to inform pedestrians about the response of the autonomous vehicle that has to do with ethics. The vehicle gives the information to the passenger, to the users of the road, to make them understand that he's going to make a maneuver. So, sorry. Okay, finally, as I mentioned before, you can see the figure there on in the right side. So we are able to adapt to different ambient conditions considering the passenger state and the activity performed. So the project has several phases. An initial phase in which the social behavior, research, and public acceptance was made. Then a research and development integration of the Alfred, this software, and then the user involvement and validation and the demonstration, which were the target. So drivers, passengers, cyclists, pedestrians, people with disabilities, children, elderly. This is why we took into consideration the social research and human factor test. And we also thought about the new potential drivers, because level 4, level 5 is not made for us, it's also made for the one who cannot drive nowadays. I won't give you the whole information you have in the website, but more than 6,000 participants, 11 focus groups with like 100 participants, 23 lab tests with almost 400 participants. So that gives us plenty of information about the user reaction. We collaborate, besides of the sibling projects, with Diamond and Mediator, and obviously with all the sister projects. So finally, which are the expected impacts of SUAVE? So we want to establish recommendations for European policy and strategies. So we want that SUAVE establish some basis of the knowledge about how this new vehicle should be. We'd like to establish the guidelines for the development of these empathic vehicles, assessing the emotional state of vehicle occupants and react accordingly. So I'd like to think more from a human-centric perspective in how to communicate with this vehicle more than purely an engineering perfect machine, because acceptance depends mainly on that. So predicting the emotional state of driver passengers in terms of arousal, we need to support artificial intelligence for adjusting the decision-making algorithms of vehicles in terms of dynamics and trajectory. This is something that started in the project, but as you suppose, artificial intelligence is somehow more complex than that, so we established some basis, but still need plenty of testing. And we need, or we want to establish real-time personalization of autonomous drive. So obviously that has to be in the direction of boosting eco-driving, related with different driving modes. So eco is interesting here, and the strategies for the reduction of non-efficient sharp maneuvers also. So it also has to do with the level of comfort. And with the development of the platform to simulate autonomous driving functions, the idea is to contribute to reduction of the cost of industry with the reduction of number of testing with prototypes. So in the project, the colleagues from SAI develop a part of software that's able to simulate most of the responses of the autonomous and semi-autonomous vehicles, so you can test it before going to prototyping. So thank you so much for your time, and that's all.
Thank you very much, Jose. I think it's interesting to see that, I mean, at the end of the day, it's the safety that will really ensure the acceptability and also acceptance of CCAM, right? And it's very good to, or it's interesting at least to see how to capture that based on emotions and perceptions and to feed this back into the systems. And I think that this is a major common thread between all your projects, to look at that sort of the more non-technical side and to feed that back into the technology. So next, I would like to introduce you to the Drive to the Future project, which will be presented by Lila Gaetanidou, who is head of the Road Safety and Security Lab at the Hellenic Institute of Transport.
Thank you very much, Susanna, for the introduction. Hello, everyone. My name is Lila Gaetanidou, and I was honored to be the coordinator of Drive to the Future project, which is now finished, and I will present you some of its results. Let's start with the overall project presentation. The project had 31 partners that you can see here, so a lot of work for me. The work was organized in 10 work packages, 45 deliverables. We had 12 pilot sites across Europe, and we organized 3 workshops throughout the duration of the project with a total budget a little bit less than 4 million euros. Our mission and objectives, the mission of the project has been to prepare the drivers and travelers, as well as the vehicle operators, to accept and to use the connected and cooperative and automated transport modes, as well as the industry of these technologies, to understand and meet the needs and wants of the future users. And to do this, we have structured out our work into 10 objectives. And in the following slides, I'm going to show you how we worked for each of them. So starting with user clustering and setting out the a priori needs and use cases. Our first work was to set out the clusters to see which are the main and the more detailed user groups. So this came out with a very detailed, like a spider web cluster, among which the main groups were the vehicle user, the operator, remote or in-vehicle, the road user, the industry, and legislators and licensing authorities. Moreover, we have defined 120 terms regarding automation, as well as we came up with a suggested definition of VRU regarding automated transport. Moreover, we undertook a very large voice of customer survey with more than 11,500 answers from all over Europe and beyond, for which we had quite some interesting results, where 48%, for instance, of the respondents were having a good or very good opinion on automated vehicles. Gender and age seem to be the main factors of acceptance, along with the frequency of interaction, the role of the person in traffic, and throughout the different modes and the different respondents, it seemed that lower to middle AV levels were mostly preferred, which seems that people are not yet so much ready to abandon the steering. After that, our next item was to define the acceptance risk assessment parameters. And for this, there were 54 risks identified, clustered in behavioral, legal, operational, and technical risks. And of course, mitigation actions were suggested for each of them. This is a graph related to the voice of customer survey showing the acceptance in the different modes. Moreover, what was very interesting was to perform a taxonomy of the skills and knowledge needed for professionals for each mode in order to operate with AVs. And as you see in the graph, this is the example for the rail transport. This was done for all modes. And skills and knowledge of different areas were identified there. As I mentioned before, we are dealing with all four modes of transport in Drive to the Future. So we try to identify transferability of measures and what would be the possibilities for that. And so a database was constructed with solution and parameterized transferability options between the different modes. Finally, research questions and use cases were defined to be used later on in our piloting. As another part of our work has been the behavioral modeling of autonomous vehicle users. In this, we started with defining the data analytics and reviewing methods already used in the past, as well as technologies for experimental design. And with this, we came up originally with methodological framework using data from real-world experiments and KPIs and technological acceptance models. Moreover, microsimulation model was defined in two levels, the upper level with the in-vehicle interactions and the lower level with vehicle-to-environment interactions. And this was tested in two ways, for the interaction of AV and surrounding traffic and AV and pedestrians. A conceptual behavioral model was also developed within the project, taking into account meta-monitoring, preferences and target state, expectations, learning and behavioral adaptation. Sentiment analysis in the social media was performed with more than 100,000 posts analyzed from Twitter, Reddit, and YouTube, identifying the fears of the people regarding AV, which seemed to be the most significant ones: first, safety, and then employment issues. Finally, from all this work, a simulation platform tool has been identified, which incorporates the data collection, the modeling, the use cases, and the impact assessment, thus providing a holistic approach. Going on to HMI, which has been one of our main target areas and testing items. Our mission was to define the optimal HMI for different user clusters and different levels of automation, setting the ground for acceptance raising. To do that, we started with benchmarking and collection of good practices. Also, a software for predicting users' emotional responses has been defined and tested, along with principles for effective, persuasive, and trusted HMI and strategy for interaction with other traffic participants. All this was taken into account and went to our pilots for testing. For users with internal and operator HMI, and user tests on interaction with VRUs. From the test results, the HMI principles were optimized, but also personalization and adaptation strategies were defined. Finally, reaching the ultimate product of this work, that was the HMI development toolkit, which is a software that can help HMI designers to make personalizable and adaptive HMI design for automated vehicles. Training was also another main pillar of our work. So the training needs were identified for all four modes of transport. 18 training programs were developed, and selected material of these was integrated in e-learning module and in some VR tools. Acceptance creation measures with users' feedback were also investigated, and recommendations for future certifications, requirements, and needs were developed in order also to strengthen the employment part of the worries about employment in AVs. And these recommendations were also communicated to working unions and members of the parliament for consultation. Our testing, we had over 2,400 users participating in our tests and providing feedback, 12 pilots in 8 countries, a 3-phase piloting structure with simulator pilots, test track and real-world pilots, and demonstration and training pilots. You can see some pictures from our pilot sites, as well as our demos we did in different events, and of course the results were consolidated to lead us to the impact assessment and also correlation to mass, together with a suggestion of ESOP extension for AV. So from the results, we saw positive or neutral impact on user acceptance for all use cases and in all transport modes. Well, impacts were also positive for most of use cases for the other impact areas as well, safety, efficiency, etc., environment. We had some interesting findings, which we call myths and facts, about the autonomous vehicles, indicatively mentioning the fact that even though low speed is considered as safe, because you can anticipate the movement of the vehicle, it was in many instances in the pilots and also in interviews with users considered as unsafe, because it might lead to unnecessary overtakings by other road users of overtaking the shuttle or the AV by other road users. Also, we found that training affected mostly willingness to use and not so much trust, and this was really mainly because of concerns about cybersecurity. And also, what was nice to find was that even the experienced users declared that training was useful for them and they still learned something new. We also worked on the correlation of AV with mass and related business models, as well as a proposal for extending the European Statement of Principles for HMI on automation level 3 and 4. Ethical, safety, security, and legal issues were also part of our research. I'm going to go through some main findings very quickly. The gender dimension should be integrated in all phases of policy. The user acceptance, ethics, social inclusion, and impacts of labor market were some of the most important concerns. Ethical implication, the safety challenges, and their links to the interaction with other road users. And also the issue of responsibility, either as civil liability for accidents, liability for defects with AVs, criminal liability for accidents, and how important it is to define the responsibility for all parties involved in the system. Finally, after as a sum up and final outcome of all this work, we have proposed business models, a business model suite for CCAM with 5 models fully specified and rated, 12 exploitable products with their exploitation plans, guidelines and policy recommendations regarding the support vehicle and equipment suppliers in design of AVs focusing on HMI, supporting training providers for awareness creation activities, and also providing the authorities with policy recommendations. Last but certainly not least, we have proposed 5 roadmaps, 1 per mode, plus a multimodal one for 3 horizons, short-term, mid-term, and long-term, and setting out the main targets for raising user acceptance in the next periods. Finally, about the expected impacts of the project. First of all, regarding user acceptance, over 2,500 users have come in actual contact with the systems in our pilots, and over 12,000 users have been involved in terms of surveys and questionnaires. The definition of rules, good practices, alternative designs and display options, both in in-vehicle and external HMI, has also raised user acceptance, as well as the development of the HMI toolkit that would help the developers of the future to adapt their HMI according to the user needs. In terms of safety and security, 18 training programs have been developed, incorporated also in VR, AR, and in-learning to make the users more aware and able to safely use the systems. The adaptive HMI is also helping to minimize the risk and to enhance the interaction with the system, also inside as well as outside of the vehicle, and interaction with their use, as well as behavioral modeling, also contributing to safety and security enhancement. In terms of traffic efficiency and the environment, training the operators and providing them with adequate macrosimulation applications will improve their decision-making, thus leading to optimized travel times and times spent in queue, thus decreasing consumption and emission and increasing traffic efficiency. Whereas the training passengers and other road users could help in mode shift and decrease personal vehicle use, especially in conjunction with the use of mass, thus also improving efficiency and environmental aspects. Finally, the socioeconomic and market penetration and the policy and regulatory framework impacts. Training again will raise the willingness to use of the users, and along with external HMI solutions that make it more clear for them. And of course, the role of AVs in the deployment, training and defining the skills and knowledge, as well as certification aspects, will help transportation professionals better accept the system. And also in terms of policy, the overall contribution of Drive to the Future is to define the framework for the industrial political decision-making regarding the AV evolution and broad deployment, highlighting the employment implication, suggesting the European Statement of Principle extension, by issuing the policy guidelines and recommendations along with the 5 roadmaps, helping the policymakers in their future initiatives. So this is all from me. I hope I'm good in time, and thank you very much for your attention.
Thank you very much, Lila. It's good to see also indeed research on sort of the needs and expectations of these different user groups. And also what I think is very interesting is sort of a mapping of all of the risks that are involved, because what we need to do, of course, is to look at the positive but also the negative effects and rebound effects that could happen with the deployment of SIGEM, again, in order to best anticipate, or to anticipate as best as we can, this transition and also this disruptive technology. Next, I would like to call to the stage Alessandro Barison to present Trustonomy. So Alessandro is a software engineer at AlgoWatt, and we'll talk about how to build trust within the machine, the system, and the vehicle. So the floor is yours.
Thank you, Susanna, for the introduction, and good afternoon to all of you. I'm Alessandro Barisone from AlgoWatt, and I'm here presenting today. I'm very happy to present the project Trustonomy. Our motto is building acceptance and trust in autonomous mobility, and we did it for 3 years. For more than 3 years, the project was concluded last July, and the consortium was made by 16 organizations from 9 countries. We gathered together 3 universities, 3 research institutes, 6 technology providers, 3 automotive providers, and 1 stakeholder associations. Differently from Drive to the Future, the project Trustonomy concentrated on different modes of road transport, starting from lower automation level, where the human driver is still in charge of the driving task, and then moving up to intermediate automation level, where the vehicle increasingly takes charge of the driving task, but may ask the driver to take back the control in case the operational design domain is reached. So there are situations in which the vehicle can transfer back again the control to the vehicle, to the driver. And we did it through 6 main specific objectives. The first 2 are more about the automotive technology assessment, with the assessment of DSM technologies that are video-based systems, basically, that are made for assessing if the driver is really capable of driving and can still take back the control from the automated system. The second one is the assessment of the HMI designs. We did it in 2 different ways. One more related to ergonomics, with a digital twin of the cabin of the vehicles and a simulation of the driver movements with the motion capture systems. And another one more related to the communication between the driver and the system, with audiovisual signals and more. Next comes 2 pillars more related to the automated vehicle research, with an automated framework for the decision support and covering the early warning for drivers when the request to intervene is supposed to occur, and the trajectory planning in case the driver is not able to intervene and then an emergency maneuver needs to be provided. Also, the project looks at what comes after the request to intervene is issued, with a driver intervention performance assessment. We established a set of measurements that decide if the driver has properly regained the control or several warnings need to be issued to prevent the collision. And at the heart of the project are also human factors, with a pillar about driver training, where we, across all transport modes and also both for professional and non-professional driver, provided different curricula, novel curricula, tailored for the level of automation of the vehicles, and evaluated this kind of different trainings across the users, basically. Last but not least comes the measurement of performance and trust, with a specific framework developed by the University of Leeds through surveys with users and also with a driver simulator experiments, where we adopted also some sensors on the simulator, like the ones that Project Suave previously hinted at. So next comes a video where the highlights of the project pilots will be showcased. Watch out for the icons to look for the combination between the pilots and the specific objectives that were implemented in each location. The pilots were 4 in 5 countries, European countries. The first one was run in Poland and Finland, the second one in France, the third one in Italy, and the fourth one in the UK at the University of Leeds. Okay, moving forward to impacts, the project delivered methodological and industrial innovations and cooperated with the advisory board. Our moderator Ingrid was a member of it, and also with stakeholders, both from academia and industry, in the Trustonomy panel. We also investigated the user acceptance and trust in intermediate automation level with the request to intervene scenarios, and released the scientific publications and research datasets that are available on Zenodo and on the project website as well. We issued some guidelines for the awareness increase and skill improvement for automated use cases. And also, we focused all our design to the user, to the driver, for these vehicles. Next, we contributed to the EU Sustainable and Smart Mobility Strategy with a continuous engagement with other projects, with associations, and with other SICAM initiatives, such as the association. More in detail, we provided a recommendation document about the usage of simulated environment for DSM driver state monitoring, with the input generation, simulated input generation for different DSM systems, varying sensor position and parameters for the same driving session. And also, this enables repeated system evaluation, changing some features of the driver or of the vehicle or of the external context, like the lighting conditions. Then we provided some guidelines for HMI designs, considering multimodality for the request to intervene signal, combining visual and audio signals, and also seat vibration as an additional way to provide that signal. We also suggested to harmonize these signals across vehicle models and manufacturers to try to standardize and to get the drivers more comfortable with this kind of situation. The document also included something about driver training, where we considered that online training was way more effective than reading a manual or learning using an ADAS by reading some document. And also we consider ICT-based training courses and online tools, but with an evaluation of a professional trainer, because it's not enough to go on a platform or watch some video, but something more is needed for useful training. An additional paper was, a position paper was issued together by project partner ITS and the EFA, the European Driving School Association, moreover on driver training, considering the need to adapt the current driver training curricula to future vehicle features and future driver needs, considering also the retraining needs for people that are not only professional drivers, but people that got their license many years ago, where such driving aids were not so available. And also to include always practical training, because only a professional trainer on a car can help the driver to gain the right level of confidence with the vehicle features. Because one thing that emerged in the simulations and also in the practical sessions is that drivers tend to overestimate their skills or have overconfidence on the vehicle capabilities, even when there are some limitations due to the vehicle or to the external context, the external situations. There is more on the project website, and thank you all.
Thank you very much, Alessandro. Again, awareness, skills, training are other sort of key words that we see coming back in all of these different projects. with the idea, of course, to strengthen safety and trust, which I think will be very important as we move towards a transition phase, which will be inevitable and which we will have to deal with. So yeah, last but not least, I would like to introduce you to Frida Kuhl, who is from Itellata Innovation in Estonia, and who will present Pascal, so a project that aims to ensure citizen acceptance, so going a little bit beyond maybe the vehicle, the driver, and its direct environment, and to see how they are responding to that in real life situations. So the floor is yours.
Thank you very much. This is the clicker? Yep. Okay. I'm happy to be here. You have already heard from our sister projects. All of them focus on slightly different aspects of acceptance of automotive mobility. The Pascal project was basically a very psychological project. Yeah, we had a lot of behavioral scientists that helped us design every single aspect of this project. What is it all about? And what sets us maybe also apart from the presentations you have heard? So the main objective was to enhance the driver capacity to operate the CAF. So we also worked with driving training institutions like the Automobile Club in Italy and real driving schools in the UK that focus not only on professional drivers that are already on the road, like truck drivers or bus operators, but also on novel drivers. Let's say the next generation of drivers that need to already be able to operate lower levels of automation with a lot of confidence, and that should use them the most effective way. Then the general mapping of the public acceptance of CAFs. So what are the factors that really influence people's opinions of CAFs? How can we increase it? For this I will present to you a multi-dimensional map, because here we took into account especially also vulnerable users, for example, people with disabilities, elderly populations. We took into account also the digital nomads versus digital migrants debate that is going on, so the intuition of people to use digital systems. Then we also developed, tested, and validated different human-machine interfaces to see how psychologically we can bridge the gap of a driver support that is missing. So if you have a problem, there is no driver, who do you address? How can you address them? How can we make this accessible to everyone? What is the difference in the perception between women and men, for example, in security on board as well, especially when we think about shared or public CAFs. And then the final outcome of our project, that is our holy grail, and I hope all of you will have a look at it, is the Guide to Autonomy. So it's like a really big toolbox of over 100 recommendations that we put together that come from our technical work packages, but also from the psychological side, and that kind of is the brain or the outcome of our project. So we want really to promote this to you, also to use it really as an actionable tool. Okay, so maybe now I can go back to just giving you the general overview over the project. So the project was set to last 3 years, but we eventually got a 6 months extension due to the COVID time that already my colleagues also hinted were kind of difficult for them to implement pilots, which was the same for us. You can see we are a really diverse consortium. We have research institutes, universities, but then we have also SMEs, we have consultancies, we have the European Blind Union as a civil society organization, and all of these bodies come together in a quite complex way. I don't want to bore you too much with all of these work package descriptions, but but I am obviously. No, basically, what I would like to would like you to focus on is obviously the 4 pillars. The one pillar were surveys that we conducted that were set up by our colleagues in Mannheim, the University of Mannheim, that received more than 6,000 replies. So we really have a huge data pool and very statistically sound data from this that included also, for example, disabled people specifically, and that I will tell you a little bit about later, because we also developed from this a widget that you can use. So you can play around with the data interactively, and it's a very intuitive way to kind of explore this large data set. Then we've moved more into the validation. That was a very, very big part of this project, was people, like exposing people to actual testing and validation. So we had a few simulators. Some of them were a little bit crazy. We had, for example, a helicopter simulator, so an autonomous helicopter flight. But we also had different simulations that simulated not just the inside of the car and the interaction with the CAF, but also the interaction with the outside of the car. So for co-road users, how does the car communicate with them? Do they feel secure in the decision they're making? And so on. Then the big part was the trainings, of course. Like I highlighted earlier, we developed a home study simulator. So the idea of this home study simulator is that most of us who have a driving license, I assume the majority in this room, we will not go back to driving school to learn how to use ADAS systems correctly. So maybe having something like a home study simulator can be a more accessible way to help actually even experienced drivers to rethink a little bit the way they use autonomous features. And then we had 5 quite large pilot studies that took place all across Europe. One of them was a high-capacity autonomous bus, so a city bus, that we also simulated some, let's say, stressful situations. We also put people in the bus. We simulated malfunctions. We put people in the bus at night, alone, in a group, a woman alone, a man alone, with children, and so on. Then we had the autonomous driving training that was implemented in the RED driving school in the UK, and an autonomous bus line that is the first bus line in Europe that runs in mixed traffic at the time. So it ran in open traffic, and we also captured the acceptance of people outside of the bus. Are they, like my colleague highlighted earlier, do they get road rage? Do they try to overtake the vehicle? Are they patient? Do they recognize there's no human inside? That was kind of the questions we wanted to test. Then also a very big objective of this project was the shared and connected transport. So how do people perceive sharing a vehicle? And the vulnerable travelers. Now here it goes. So I will not stay here very long. This is just so you see how the EU funding is spent. So you can see a very high number of participants and really a lot and very diverse set of activities that we carried out. Yeah, my favorite of this was, by the way, that we wrote over like 30,000 pages. So I'm sorry to the reviewers of the Commission who had to review all that. Yeah, then I talked earlier already about this multi-dimensional map for public acceptance. So this is a tool that you can access, and you can interactively drag and drop different different indicators in the different sections. You can create any kind of graph that you want from it. You can create bar graphs, pie graphs, whatever, heat maps. And this is, I think, really interesting for future research, to kind of use not just have the data set itself, but to have a very easy way to actually gather insights from the data. Then another objective we had was to optimize and validate already existing transport solutions. So you can see some of the results of our service. I will not go into them, unfortunately. They are very interesting, the results, but this presentation has to be short. But you can see, for example, that we used VR headsets to help also people with wheelchairs to take part in simulation activities. Or we had this 360 arena that kind of helped us to see how people interact when they are approached with a driving vehicle. If they stop, if they feel inclined to go forward, and what they observe on the vehicle. Then we had the shared modes debate that we separated basically into 3 categories. One is a privately owned vehicle, so the Tesla you can have in your own home. One is the shared vehicle a la, let's say, Share Now services, so vehicles that people can rent out. They still use them individually, but they might include ADAS systems, advanced ones. And then finally, the public HAV. The idea, I think, that most of us have in the mind that can also include several people at a time, on-demand mobility maybe. Yeah, so these are also included in the widget. And here you can see my colleague Patrick in Luxembourg in front of our shuttle there. Then we wanted to see the driving training needs, like I said. We used a range of different drivers for this. So we had some military drivers, like you can see, that are specialists on vehicles, over professional drivers, of truck drivers, to really learners, like people who literally do their driving certification in this moment. And we exposed them to a training methodology that we developed inside the project. And some of them didn't do it, and we exposed them to like similar situations in the real world. We saw that the driving training, despite the experienced drivers that are not professional told us they don't need a special training, they perform much better afterwards. So it is worth it to really take people from the road and, you know, re-explain to them how ADAS really works and lower levels of automation. Then the University of Leeds devised this evaluation framework that is very complex. But basically they used data not just of our surveys, but also of onboard trackers, of cameras, of trackers to detect like the skin resistance, to see if people are really stressed or not, if they are lying or not. So this was all devised by them, and also the data was analyzed by them. Then we have this in-person kind of confrontation with CAF technologies. So you can see the helicopter simulation on the bottom left. It looks like a big fishbowl. The home study simulator, of course, that I talked to you about. And on the bottom is the high-capacity autonomous bus pilot that included, for example, an HMI on board for people to ask support because we knew that the bus was going to break. Of course, we knew that there will be problems that are simulated and they will need to ask for help. So we wanted to see if the HMI is sufficient. And of course, we noticed it's not 100% accessible, but it provided a great help for them to connect to the control center. And also on the bottom right, you can see a person actually taking the hands from the steering wheel in Luxembourg. Luckily, nobody got hurt. Everything went to plan, except one person who didn't really understand that they have to put the hands back on the steering wheel after a few seconds. But it was quite interesting to see the reaction of people when they actually take their hands off on the highway. Yeah, and then finally, like I already spoiled maybe in the beginning, we devised the Guide to Autonomy. So this is really a central platform that collects all of our work together, also some of the recommendations of other projects. So we also joined like an Automate collaborative group that consists of some CCAM projects that we kind of try to pull all knowledge together, not just ours, so there's not 15 toolboxes in the end. Yeah, and I implore you to go and check it out. And, well, if you want, you can scan it right now. I will leave it on for a few seconds. And, of course, you can find all of our input also on our Zenodo community, so there we have all of our papers that are published and all the data sets too. So if you want to use with the data sets, they are there. And yeah, I think that's it from my side. Feel free to also email me or message me. I will be here later as well. And yeah, connect on my LinkedIn if you like. Thank you.
Thank you very much, Frida. So everybody have a look at the Guide to Autonomy document and also the interactive mapping and tool to answer all of your burning questions. I'm sure that there's a lot of relevant, 100 recommendations, right? That's a lot. So now we will move on to the second part of the session, which is a Q&A. So again, if you have any questions, I will let my colleague Ingrid Skogsmo now moderate this part of the session. And yes, looking forward to hearing from you. I mean, very interesting things have been presented today. So Ingrid, up to you.
Yeah, let's see. Yeah, it's working. So, well, I'm Ingrid Skogsmo. I come from VTI in Sweden, and this has been a very interesting session, I think, not least since I did work in the Commission a couple of years ago when we were launching this call. So it's super cool to hear all these projects now reporting. And I think this session has spanned quite a wide view of driver behavior and acceptance factors. We have looked at, or we have heard about emotional assessment, psychological aspects, driver state monitoring. We have looked at training. We have looked at training that is also not only for the drivers but also for passengers, even home office drive refresher training. And we heard about Alfred and tools of different kinds. So I think we have spanned over quite a broad range of things that work on towards the acceptance and behavior aspects of connected and automated mobility. And I will open it up to the audience, but I thought I will just warm up with one question to each of the participants here. If we first take the SUABE project, this concept of the empathic vehicle, how do you think that it does or it will increase acceptance of automated vehicles?
So thank you for the question. This is not really something new. It comes from the field of robotics. You know, the uncanny valley in robotics is related with the resemblance between a robot and a human being and the level of acceptance of the robot. So we want to imitate with Alfred is that to cover this uncanny valley and to reach a level of acceptance similar to the robots that are developing today.
And when you say acceptance here, what do you mean?
It means that in general, for non-technical people, when they have the feeling of being driven to a place by a machine, by a robot, they have the feeling that they're being used like a sort of piece of, carriage or luggage. So they do not feel comfortable. They don't feel that this is something that might react in case they need it. So adding this layer of simulated humanity made them feel more relaxed, like there's somebody on the other part listening to you. But we have to be careful and do not fall in the mistakes that some autonomous answer machines have fallen, in which you quickly detect that they are not listening to you. So we have to be careful with this effect that some technology today, and I don't want to say names, but all of you interact with your mobile phone and you say, okay, I will call myself. We have to be careful with this uncanny valley because it might bring a lot of problems to the automotive industry because of the rejection of this technology that's very expensive. And besides, it can save lives. I really believe that, but we need to cover that gap.
Okay, thank you. Frida, you were sort of also thinking about this, that somebody that you can get in touch with in case of you need that. Would you agree on the same view of what acceptance is, or what is your take on what acceptance would be?
Yeah, for me, acceptance is related to a lot of different factors, of course. But I think what you're referring to is maybe the intuition to use the technology. Like you don't feel like it's a foreign system. You don't feel scared of it for different reasons. There is privacy, safety, security. There's a lot of different factors. But one big problem, for example, that we found was that people are very, very concerned about the safety. And when they actually go on board, this doubt disappears in a lot of people because they understand suddenly that the machine takes care of them, but it's not an intuitive experience yet.
All right. And Alessandro, since you worked so much with trust in Trustonomy, would you have a different take on what acceptance is, so if it relies more on trust or?
Yeah, trust is a fundamental element of acceptance of automated vehicles, and we in Trustonomy understand that trust is not something that is static and can be brought to people and kept forever, but how the vehicle behaves somehow influence the driver perception of trust, and trust can be destroyed or at least hampered by some situations. But if the vehicle reacts properly and the vehicle communicates properly with the driver, trust can be more or less rebuilt also in a very, very short time.
That's good to hear. I think you always hear that when a brand is suffering from some backlash, that it is destroyed very quickly and it takes a long time to build up. But that's good to hear that maybe
or
here...
at least the vehicle needs to explain to users what is happening, basically, in the best way possible.
Mm-hmm. And if we then think about Drive to the Future, would you agree, Lila, on what acceptance is, or how do you? Because you have looked at the different modes, and did you find differences on what acceptance is for drivers in different modes?
Well, I think acceptance varies not only between different modes, but also between different users. Because it's a different thing to speak about the acceptance of a driver who in an AV is no longer a driver. And it's a different, there are different parameters affecting the acceptance of a passenger that goes in a bus that now has no driver and it's remotely supervised or even not. Or the acceptance of the transport management center operator that has to manage with these vehicles, and so on and so on. What is, I think, the common denominator in this, in the acceptance of, in all cases, is the experience with the system. I mean, what we saw is that the more people were in touch, let's say, with the system from either perspective and from either role, their acceptance was better. They found what they liked more, and they found how they could adapt it to their routines or their work or everyday life. So I think it's experience is the most, and of course training, because they need to know how to use it, and then come more accustomed to it. Thank you.
Susanna, and then I'll open to you also.
Yeah, maybe just a quick comment. So I think it's a very difficult question to answer. What is acceptance? I think maybe one thing, and it was kind of mentioned. I mean, it depends also on what people understand in terms of what is automation and what it can really bring to them. And based on that, you can accept it more. But I feel like there's a variety of different understandings of what automation is. So maybe just one quick question to the different projects. What were the main sort of differences that you find? I mean, you've worked with different stakeholders, you work with different, with user groups. The main differences in terms of understanding automation that you have found within your research. I mean, were there any major differences or similarities in that sense?
Okay, Frida.
Yeah, maybe I can answer this, because we actually had a very big challenge, because in our project we talked about CAFs, connected and automated vehicles. We actually noticed that there was a huge difference in understanding between these two factors. People really perceived them completely differently. They were super scared of automation, but then with connectivity, they were using it every day. Actually, it's a thing we use every day, sharing information. So in our project, that made a very big difference. We actually started to unlink it a little bit and to give real-world examples with it, because people found that the word automation or autonomous is a very abstract concept. They think of a robot. So yeah, we tried to put maybe also a little bit of focus on the connected part and collaborative part. But this is something we noticed, that automation is not very intuitive.
Is there anyone else of you who want to comment on that?
Yes, something more could be said about professional and non-professional drivers, because professional drivers are more or less more prepared to automation because they follow trainings. They have probably on board of their vehicles already lower level systems, and so they are more also interested because they spend many hours of their day on the vehicle. They are more interested on the automation side of things. On the other hand, the general public, the people that buy new cars, will get new automation, but there are also people that could not afford or is using used cars that have no automation at all, and so the gap is wider for them.
Yeah, we will do. Let's do two quick comments there, and then we'll go to the Q&A.
Okay, very quickly, I think that it's a matter of training, as we mentioned before, so that we help people understand better what is connectivity, what is automation, and also awareness campaigns and the dissemination of the notion, and not only of the products, is very important.
Just to complete the round very quickly, there's 2 points. One is related with communicated vehicle. So it's interesting that you say okay to Facebook, Instagram, LinkedIn, whatever, and when we talk about sharing data of the vehicle, you are like, okay, well, what I'm sharing? So we have to lower barriers in that sense and make feel more comfortable about this sharing data, because you are sharing your whole life in the Facebook, for example. On the other hand, is brain is lazy. If you are saying that something has a level 3, your brain will think it's a level 5. I mean, once you let your something dedicates instead of your brain to do something, your brain automatically will, will not do that task. So we have to be very careful with this part about automation, because human being, no, but our brain is animal. So we behave like animals. So have to be very careful with this understanding of automation.
I understand there are questions here, so that is really good. Yeah, let's go there first. And say your name.
Marco Tella from Extremium, Human-Centric Digital Technologies. So I very interesting presentation. Actually, I would like to I didn't see one point, which I think it was somehow a part of the request of the call, or maybe not, because at the time I was at Infineon and we were making a proposal developing this, but it was not retained for funding. So I was okay. Now, how do you quantify the emotion and all this, let's say, fuzzy aspect in your project? Because I'm sure you did it, but I did not see it in the presentation. So, coming from something which is, of course, emotional and therefore difficult to quantify, to something that needs to be quantified, because at the end we have to take some precise decision and taking into account these aspects.
Is this something for Alfred?
Yeah, okay, I will try to answer quickly. It's not here, but I would like, maybe you have already done it, but in Suave project, in the web page, in references, you can find the scientific papers we publish about that. Basically, when we have a physical reaction, when something appears to us, the brain reacts and our physiological signals change. Because when you are scared, your body reacts for fighting or for escaping. So this is primary, and your body cannot avoid to react. So there are some physical changes. There are some hormones provoked in the body, and these hormones provoke that there are some changes that can be somehow visible. Changes in the pupil, diameter, changes in the fluid of the blood. Heart rate variations, breathing rate variations, and also variations in the level of sweat in your body. You start to emit humidity under certain circumstances. These parameters can be measured, as I mentioned before, using systems that are directly touching the body. We are changing to other systems that are not touching the body, like radars or cameras, to detect different ranges of near-infrared spectrum or separating the color of the body in different bandwidths. But finally, you are obtaining some parameters. There is literature that relates that parameters with two basic reactions. In the literature, you will find it related with, as I said before, arousal and valence. Arousal and valence is a quick manner to explain in a two-dimensional parameters the level of the intensity of this emotion. It depends on your body changes, and also whether this emotion is positive or negative. So in some manner, you are making a sort of frame with two dimensions where you can find that.
Shall we? I think that is. I hope that is a good explanation.
There are much more, but you can find the literature.
Yeah, I understand.
Okay. But basically, this is the basis.
So there is a way to quantify it,
Yeah.
and we can think about that next time we feel a feeling that it is arousal and the other balance. Okay, next, Chark.
Yeah. Thank you very much, Ingrid. Thank you very much for the presentations. Very relevant topic, really. So, Chark Weitzinger, Tomato Europe, I think I said that. I have a question which is also related to human factors here, and that is, I'm not exactly sure, I saw it maybe a little bit in the presentation of José. If it was not covered at all, my mistake, sorry for that. But I think everything here has to do also with the human perception. So the situational awareness, the cognitive awareness of what's going on, because I can only accept something that I understand at the moment when it happens. And I think that automated transportation will come with distraction, with cognitive secondary tasks, anything like that. Maybe the question is primarily to José, if I missed it anywhere else. Did you cover that? How did you cover that?
How do we cover the situations?
Situational awareness, cognitive distraction.
Yeah, okay. In that case, we are not covering distractions. We are only trying to elicit emotions. It's true that I said before, in our experimental sessions, we cover only some cases, some scenarios in which we try to elicit some emotions. Everything was not covered, and it's true that we should cover in other situations. What we found is it's quite difficult to elicit an emotion, because driving tend to be tedious, tend to be, quite static. And even it's more difficult even in a driving simulator. So we found higher reactions when we try to make the Wizard of Oz, when we simulate a car that's driven by a real driver, whilst the people think that there's no driver on the wheel. So then we make that the motions are, higher. But we didn't cover distractions in this case. It's only a small case. I don't know whether I answered your question or not.
Yeah, in a way, you said you did not, and I'm wondering a little bit. It sounds to me like a fundamental of automated driving to understand.
I cannot hear you very well, sorry.
Sorry, maybe. Okay, I have to be much closer here. So, yeah. So in a way, you answered because you said no, you did not. I'm wondering a little bit because to me that sounds like a fundamental of automation that the drivers are aware or cognitively active.
But let's see, was anybody else
Did
covering
anybody else
that?
cover that? Maybe that's then.
Always level 4, level 5, so you don't have to be really aware. So probably in level 3, this is awareness, but level 4, level 5, you don't have to. Level 4, you have the time to be aware when the vehicle says, okay, I'm going to be out of the highway. We are not talking about level 3 in Suave.
I tend to say that from level 2 to level 4, you should do that. But okay.
Let's see if that was covered by, for example,
I think even
Pascal.
in level 5 it should be included specifically for people with disabilities. Because, for example, for a blind person it can be a really, really, really big advantage to know what is going on outside the vehicle, the environmental information, the context they are in, what is going on around. In our project what we did was that we had very busy simulations. So we tried to really simulate very different scenarios, real world scenarios on the street, and realistic scenarios with not just a straight line on the highway where nothing happens except maybe one car passes you, but with a real context around it, let's say. And I think in that sense maybe the pilot we did in the autonomous shuttle we had was quite interesting because it was operated in mixed traffic, so together with pedestrians, bikes, cars, in a totally open street. And a part of that pilot focused only on getting the perception of people around the vehicle too. So how do they, in the whole context, perceive the vehicle? So in that sense, we took into account a lot of the situation around the human. A lot of the people in our projects were ergonomists too, that focus a lot on the human factor in the context of the system, in the social system, how it interacts with the technology. So that is something that we touched upon, but maybe we can also speak about it afterwards. I would be also really interested in hearing from Jose more about that.
did Trustonomy at all look into this?
We dealt with this indirectly and from the driver perspective through driver state monitoring systems that usually are able or try to detect distraction. It's one of the tasks that driver state monitoring outputs before the vehicle issue an RTI. Also, driver intervention performance assessment addresses failure of situational awareness. And in the trust part of Trustonomy, the simulator experiment, we used as a proxy of the awareness and the distraction, the propensity of the driver to engage in non-driver related tasks. We had a game on a tablet, and the more the driver gets distracted, the more the driver looks at the screen and not at the windshield.
Lila, did you have any aspects of cognitive distraction at all?
Well, it wasn't in our main focus. However, there was some emotional monitoring feature in consideration, and also we had through, but mostly through questionnaire answering on the situational awareness also for other road users. In-vehicle passengers, for example, in shuttles, but also other road users in order to capture how well they could understand the external HMI, for example, and in terms of their interaction with the AV.
I would say in all fairness also that I do believe, because I read through the topic before this session, and I think this with the cognitive distraction was actually topic of a previous call, so or a subject of a previous call. So I actually don't think it was explicitly asked for, which can explain why it was not addressed also, to that extent that you may have expected. All right, yes, the question here as well.
Hi, Mehmet Golhan from Logica. Thank you for the presentation. My question is about how CCAM and your projects in general cooperate with other clusters. Because we have projects where we use 5G, EU open data spaces, decentralized AI, and somehow these are not mentioned at all, neither this morning, yesterday, or now. Whereas, so it sounds like CCAM is really focused on automated transport, but connected and cooperative bits definitely need 5G, EU open data spaces, and decentralized AI. But somehow it's not mentioned at all. Is there, how can we kind of find the links and collaborate with these projects, is my question.
I don't know if you feel automatically, yes, this I want to answer. I think this, in all fairness, I think it's a super relevant comment, but I'm not sure whether it's fair to put it exactly against this topic. In all fairness, that is about driver acceptance and or driver behavior. Or do you see a very close coupling to exactly this topic? If I may.
I think I do in terms of EU open data spaces. It's about data sharing and user behavior and how different pilots will share their data and how vehicles and users share their data and privacy issues. Obviously, it's very related in my thinking, but obviously, you know.
Well, let's see.
And also, acceptance has a lot to do with the pathways that you've described yesterday and today in terms of the level of automation right now and how long of a marathon it's going to be get to the ultimate objective of the CCAM, and that there are, in addition to the robotics related challenges, you have all sorts of legal challenges, public policy thinking challenges, marketplace challenges, etc. And all these things are also dealt with in these other projects in a very similar fashion. So I thought that there's got to be some commonality, some collaboration here.
Well, I think what, as I said, I don't say you are wrong. I think this is a very important point. It may be that we find a coupling, because I think what you said, Frida, about that when you threw in connected, it sort of got less dangerous to everyone. So yes, there is a coupling. Privacy could be a part of trust. But I saw that, Lilla, you sort of had an idea.
I was just, I agree with you, and I also agree with Ingrid's comment that this was not the aim of these projects. However, we saw from our results how much of a fear cybersecurity, for example, is for the users. And this is something that probably reduces their trust to the systems. What I would say is that it would be very interesting for the upcoming calls to couple these two areas. Food for thought.
Susanna?
Yeah, maybe just a quick comment. I completely agree also with your statement. I mean, sort of this collaboration that needs to happen between the project is absolutely key. The projects have to build upon existing work, future work, current work, and I think that this, you know, these 4 projects have done that very well because they've collaborated with a couple of other projects. Mediator was cited. I mean, so that is already, I mean, quite a difficult task in and of itself. So I think that the projects have done that well. With regards to your question, I mean, the scope of all of the topics that are very important that you're raising, of course, will have to be integrated in the work that we're doing on CCAM. I see that as a more general sort of endeavor, because, I mean, of course, the mobility data spaces is very important. Cybersecurity, I mean, all of those different things have to converge ultimately. So is it, yeah, I would agree also with Ingrid, is it a fair way to put this on the shoulders of these projects? I see the links, of course, but this is where we also have our CCAM partnership to be able to coordinate all of these different activities. You've mentioned the different clusters. We're working on AI, we're working on key enabling technologies, we're working on societal aspects. I mean, all of this is coming together. So maybe to answer your question, that the partnership that we now have in place, this public-private partnership, will help to coordinate all of the different research activities and results as we move forward. Maybe, again, food for thought and a quick comment, yeah.
All right. Another question here.
Arne Wolter from the Initiative of Safer Roads. I was just wondering if, in terms of contextual factors like road infrastructure, weather, time of the day, traffic volume, was it taken into account in any of the projects? Because independently if it's autonomous car or not, the stress situation of a person is completely different depending on the context and the road infrastructure, if the road is bumpy or not, if it's raining heavily or cold and the conditions are difficult. So was that taken into account, and to what extent was it measured?
Yeah, when in SUAVE project we focus on Alfred, but AMI, that's the HMI, has contextual information. So the information given by this HMI depends on the weather, depends on the time of the day. It takes also in consideration other information in order to deliver properly the information at the right time, because also have the GPS info and so on, not to give you critical information while you're in a dangerous place. So yes, contextual information is key to modulate the information adequately, and it has to be taken into account, and it has been taken into account in this HMI design in SUAVE.
Any other?
Yeah. So in our project in Pascal, the autonomous bus that is running in mixed traffic, we didn't have a second pilot that was in a dedicated corridor, of course, but the infrastructure around the campus area where the pilot is running was changed. So actually they changed the way of ride for the vehicle in, for example, in roundabouts and so on, and that was something that we asked the co-road users about, if they are willing to give up maybe the way that infrastructure is usually designed in favor of the autonomous bus. So how they perceive the change in the infrastructure design towards like integrating autonomous vehicles in the traffic.
And what was the answer?
They didn't mind.
Okay, very good.
Unless they thought it was a human driver, which happened sometimes too. Then they had more road rage than if they realized it was an autonomous vehicle.
All right. Further comments on that?
I would say that in our case, this was also, as I said, considered within the HMI design, and also after testing in the personalization features that we tried to integrate in the HMI design.
All right. Any further questions? Yes.
Yes, Eleanor Lesquin from CEA. Thank you for your presentations. I have a question about SUAVE project. You mentioned a smart cognitive assistant. I would like to know if you mean that you used a natural language processing tool to interact with passengers and improve acceptance. And if yes, did you use a GAFAM tool or a European homemade tool?
Yeah, thanks. No, unfortunately, we didn't go that far. We didn't use natural language interpretation. So the information is given by a screen. And yes, there are some verbal information from the system, but there's not a verbal communication between the user and the system. Something that in another project not related with SUAVE, we are doing in IBB, so the identification of natural language. And we would like to say that in the near future, we will have something on that field, but it's harder than we thought.
And if I understood Pascal correctly, you had something similar. You had this HMI where you could call upon help if you were in an automated vehicle as a passenger. Is that in line with what you were asking about as well.
Yeah, we defined some different HMIs. We also developed new HMIs for the outside of the vehicle. For example, if the vehicle continues without stopping, should it give a signal or not? We also analyzed the different ways the signals are perceived. So for example, we found out that sound is the key, except for deaf people. But that people are most responding to sounds, that maybe this also ties into the situational awareness. It's something that we can choose to block out HMIs, or we can choose to notice them. We also developed an HMI, for example, to highlight kind of the multimodal context inside the vehicle, so we gave the next stops, apart from the ones that are by design included in the HMI already, in the CAF.
All right, on the left side first and then the right side.
Again, Marco Tella. Well, one aspect that it came to my mind now, because you pointed out very, very interestingly. What about the human-machine interface of the future cars? How do you think it will be? Because now you see we have the steering wheels, which is almost like a space rocket cockpit with so many buttons that as soon as every time you never press the right one, so it's becoming crazy. Do you have an idea of how we could improve from this point of view? Did you think about this in your projects?
Who would like to take that one on?
I don't have any idea, sincerely. I'm a researcher, so it's difficult for me to forecast the future. What I can say is that we are the same that we were in the past, so it's very difficult to change some things, and we have a big inertia. So although I like to think about a vehicle in which I communicate verbally and something happens magically, for me it's still difficult to think about that. So I don't know, maybe inertia will guide us instead of futurism. But it's just my opinion.
Trastronomy, did you look at this? Because you had some HMI with buttons and things.
No, not directly, but experimenting with traditional media, like colored marks, icons, and audiovisual signals, and haptic feedback on some driving simulator. But for the near future, for level 3, level 4, there will still be a driver's seat, a steering wheel, and the vehicle needs to be driven like we drive today, at least in the near future. Also, the steering wheel is getting more and more complicated, but we are not at the F1 level. So there is still room to complicate things more.
And Lila, would you have other ideas? Will we complicate things more before it gets better?
Sorry. I think that how our cars will look from the inside, unfortunately or not, it's something that is not up to us, it's up to the car industry. And I think that what is most important is that we as a research community provide them with specifications or with recommendations. And most importantly, there should be some kind of harmonization between the HMI of the different manufacturers, so that it's, as it's a new thing for users, it's not completely different from a BMW to a Volkswagen to a Toyota or whatever. So I think that it is important to have some kind of harmonization of the HMI between the different makes. And I think our work is mostly on the usability and on the features, and not on the layout so much.
Yeah, maybe something that is maybe a personal observation is that actually I think there's less and less buttons, which is a nuisance for me, because I see more and more screens in the cars nowadays. The buttons are replaced actually by touch screens, which I think is a crazy idea because we are trying to dissuade people from using their smartphone, and then we install a smartphone in the car. And we don't want to go all the way to what the UK recommended now, because some highways in the UK are now open for autonomous driving. And some strips of the highway you can use autonomous features now in your car. But the UK government advertised it as you can stay back and read a newspaper, which I don't know if that is the right signal to send. I agree with Lila, in the end it's up to the car industry. But I think, for example, the way to go towards screens and tablets is maybe not a perfect development. Also, again, I know I'm keep pointing to this point, but it's not accessible. It's there is the autonomous vehicles can be used by so many people who are non-drivers right now because they cannot drive, like a blind person. And for them to have an accessible mode is really important, to have tactile things in the car and so on. I think we talked about this yesterday morning in a dedicated panel, but it would be a really big development in the car industry to take this into account from the design stage, let's say.
Thank you. And one more question here.
Yes, thank you. Rodrigo Alfael, Lindholmen Science Park in Sweden. It's a lot of talk about HMI, but I was also wondering about the driver-passenger interaction in such vehicles. Was it covered, and any findings on that? I mean, how do they speak to each other? Is that the difference between non-automated transport? So an open question to anyone of you. Did you include that in your thoughts? And that's a part of the trust level and so on, the trust from the passenger to the driver, and in this as well.
Yeah, I mean, in one of our pilots, that was exactly the focus, to simulate problems happening, and then we want the person to seek help. And the HMI we developed was basically a kind of Skype. So you are connected to the control center, and the control center helps you to navigate the situation. But I think what is missing in that is, for example, security incidences. So then we are thinking more about safety. But if you imagine you are in a public car, you share the space with someone and the person is violent or something like this, maybe the right person to be connected to is not the transport operator. Maybe you want to be connected to the police. So I think that's something, maybe food for future research, specifically on how this digital connection can work better.
Lila, I saw you were on the way as well.
It was, I think that it's in the same context as what Feda said. And also for in our test, we saw that, especially in the case of shuttle buses, that it made a difference whether there was or there wasn't not driver, an operator, I would say, in the vehicle. And this is an issue, as mentioned, of security and of the perceived safety of people when alone or with the companion. And I think that I know that there are projects in other areas, like Avenue, that has already been finished, and Ultimo, that is coming after it, that are specifically working on that, with monitoring with cameras in the vehicles and panic button applications and things like that. So I think this is an issue, and we're going to see more about it in the future.
We participate also in the Diamond project. I say that one of the sibling projects. IBB developed the case of autonomous vehicle in Diamond project. It has to do much more with the interior distribution and the use cases related with men and women differences in the use of the car. In the case of women, there's a different way of using the car now today. I hope in the future it changes. And that project dealt about the way people uses the vehicle. And then in this project, you can find the deliverable, and there's a guide in English and Spanish, also in French, in which we examine different ways of interacting, and different ways of distributing the interior, and different kind of users to accept these different interiors for different usages, like elderly or bringing kids to the school or going to the grocery. And then these use cases and how people relate, you can find it probably in the Diamond deliverable that's public, and the guide that you can download it.
All right, I think we are now just a couple of minutes from coffee, so would you like to wrap up say the final words, or would you like me to do that, Susanna? Yeah?
Please.
No, okay, but then I would like to thank first the panel. Thank you. For really good presentations that stimulated a very good discussion with questions from this audience that, despite it being between lunch and coffee, has stayed here and been vigilant and awake and alert. So thanks to all of you as well. The next item on the agenda here is half an hour coffee break, and then you are welcome to get back in here to talk about the stakeholders' experience of successful interaction and integration of R&I activities. And maybe there we can take this 5G question again. Thank you very much and enjoy your coffee.